Hello guys. So yeah, today we're going to start it on unit 2. So this is going to be exploring one variable quantitative data. So the last video we just covered the unit test of exploring categorical data. So we just explored categorical data. Now this time we'll be exploring numerical quantitative data. Okay, describing, discriminating, and describing. So we go here. It's going to be basically on reading dot plots and frequency tables. Okay. Now this one is basically on. We'll just practice and see what are dot plots. So dot plots are basically where following dot plot shows the number of players at each table at bingo builds bingo ball. Each dot represents a different table. Okay. So how many tables? So like tables if you had a bingo, like 1, 2, 3, 4 tables. So how many number of players? So there are say two tables that are empty. Okay. Two tables are something like that. Two tables if you have like one player. Two other tables you have like maybe two players, two players. And if you have more, that'll be occupied like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. In that ways. That way you can see like here the dot plots are basically how many tables are there who have zero. So no number of players. We just make like a number line kind of thing, like 0, 1, 2, 3, 4, 5, 6, 7, 8, and then we see how many tables have two players. Okay, we see actually two tables on a VC, so we just duplicate two dots there. Okay, it's basically something like where this way you can just count and see how many tables there in total. So this is basically graphing and showing how much frequency. Okay, what which table, which number of players are the most present. So what is the highest frequency here? So it's actually three, right? There's five tables. Okay, 1, 2, 3, 4, 5. They actually have three players. So the majority of the tables we could say, I mean, like not majority, but the table with the most frequency, like three, has the most frequency of the tables here. So basically, that's what we can conclude here. That three is the most frequency one. Okay, the table with three players that has the most frequency of appearing compared to the other tables. It has the most frequency or most probability of occurring. Now the majority tables. Majority tables you could say in one sense, majority tables actually have three players, but yeah, majority we could say have three players. The other ones are smaller. So other ones like two tables have two players. Other two tables have four players. The one table has five players. The last one actually has seven players. So that way, if you want to see how many tables have fewer than 62 players, we can just do is how many are fewer than two? Well, actually 1, 2, 3, 4, right? Because 0 and 1, how many they have here? Let me see. They're four. So we can just say it's four tables. There we go. So basically, if you see here, so yeah, a dot plot means each dot represents the number of players at a different table. Yes, each dot represents the number of players at a different table. So this is just representing that how many tables. So it's one table, second table, third table, fourth table, like that. These two tables have four players. So that place we played two dots over four. And then how can we use the dot plot to find how many tables are fewer than two players? Combining tables with fewer than two players. Yes, that's how we combine. Okay, we're going to. The following frequency table shows the number of Dewey pictures that have been published in each of the following categories. So this is like a frequency table here. We're saying number of pictures, how many number of magazines. So number of pictures, say zero. Okay. What is the frequency of zero? How many magazines have zero pictures? Two magazines. How many pictures have one picture? That's actually one magazine. How many pictures magazines have two pictures? That's three magazines. How many magazines have three pictures? That is two magazines. Like that. Okay. How many magazines have four pictures? One magazine. Okay. So how many published two or more of those pictures? Well, if you see here, this is two or more. If you try to see here, there's 3 plus 2 plus 1. That's about 6. So 6 actually published two or more. The other three published less than two, right? They published 0 or 1 pictures. So it is 6. It's here, yeah, there you go. So from a frequency table, this is how we can read, okay? Each row shows how many magazines published in number of Julie pictures. So yeah, this is how we can read from a frequency table. Now this is also dot plot. So now given as a scoring how students essays on a point scale, best gets the highest score. So yeah, this is actually very helpful for plotting how many students won, how many students got an A's. Like you could even make something like A, B, C, D, E. Actually, yeah, we don't have an E in college, so yeah, and then one like that, yeah. And then you can just even draw dots here, so like this. That from here you can just draw like two dots. So what is the highest frequency here? C is the highest frequency, right? Because C has five dots. Okay, so five students got C. Maybe three students got A, three students got F, and then two students got B, two students got A. So that way, we can calculate how many students are there in total. We can just add all of these numbers together. 3 plus 2 is 5, 5 plus 2 is 10, 10 plus 2 is 13, 13 plus 2 is 16. So 16 students were there in total in this class. So that way we know how many students were there, then how many students, 5 or 16, so that's the highest frequency. So a score of C is actually the highest frequency here. highest frequency as the highest frequency, we can say, because C occurs the most time. It is the kind of the mode here, okay? If you guys remember mode from statistics, the highest occurring, the most occurring, frequently occurring value. That's the frequency here. So C is the most likely grade for the student, we could say, based on the dot plot. So that each dot is representing a student. Now here in this case, they are saying each dot shows the SS score for each of the students of the given SS class. Each dot represents a different student. So this is basically representing, how many students, let's say I got a 4, okay, out of 6. So I would place somewhere over here, something like that. So, one student maybe just got a 2. That's like an outlier. One student got a 6, perfect score. Most students got, bulk of them got between the two, right? Because bulk of them are like, between the B's and C's. Or very few got like an A's and very few get like an F. So, extremes are pretty rare. Middle is the balance, bulk is in the balance. So, yeah. Anyways, if you see, what was the minimum essay score that a student received? Well, that was actually 2. One student got a 2 score. So, yeah, 2 points, I would say. Now each dot plot is showing the same data score for each student in Miss G's class. Each dot represents a different student. So yeah, this is their essay score. Oh, so I think let me, yeah. So yeah, this is showing is that minimum essay score that a student receives. This is showing. When they're asking us, what is the minimum essay score that we receive? Actually 2 points, right? Because yeah, this is saying that dot plot is, basically saying that score on a 6 point scale. So how many students got this score? That's what we want to say. How many students got score of 3? Well, 4 students. How many got a score of 4? 3 students, right? That's what we can say. My score is 2. Awesome. That was basically that. We want with this model, like unlike bar charts like those pillars, that represents, here we just represent clear dots. So in those bar charts, we just say like 4, that's pillar, like that. In this, we just say 1, 2, 3, 4, 4 dots. But for histograms are generally stacked up graphs. Okay, so for bar charts, basically histogram is a bar chart, but just the things are without any gaps. Okay, that's just the difference between histogram and bar chart. And in histogram, we generally have bins. Okay, in bar charts, you have just values. In histograms, you have bins, and they're all squashed together. There's no space between the two. So in this case, we see CEO of a rock town apparel started using an email client to help her expand her business through email marketing. The following data points represent the number of emails that a CEO receives after she started using a new email client. Okay. These are the following data points. Number of emails that she's receiving. Now we're seeing the data. Using the data, create a histogram. Okay. We can even create actually a dot plot if you want. So that way, if you see, yeah, these are the 7 days, right? I think. So it should be something like, each day. Okay. This is how many, let's say 7 dots, right? But actually for a dot plot, yeah, dot plot actually we would need is this value is actually pretty big. If you could, something to like a dot plot example, I'll just guys show you, that base. We can a little bit know more about dot plots. Something like maybe grades is I guess the best example. Let's pick grade, I think. F. I think it was something like uh something like that. And in that way you can just say how many students got A, how many students got B, how many students got C, like that. And Instagram, if you want to model that in, you can just say something like that. So like that, and then you can just say something like A. Except Instagrams, you can say like with the dots, you have to say with a like bar. That's way it's more easy because in dot plus if you have say 59 emails, 59 you can't make dots, right? That would be like literally a lot of dots. Making from 0 to 59. That would be kind of impossible there. So that's why we tend to gravitate towards, using those using those histograms of bar charts. In that way, you can say from 0 to 30, how many occurrences of that thing specific happen. We could even say here actually occurrences of each dot, like 0, 1, 2, 3, 4. And actually above 1, that would be all stuck. So if you see here, if you make a dot plot of this thing based on occurrences, okay, based on frequencies, we could just say something like, number of frequencies here, and then 0, 1, 2, 3, 4. So how many number of times this 6 is occurring? That's occurring actually once. So we get a dot here. So we and how many times 59 occurs actually once? So yeah, 55, how many times it occurs? So yes. It's something like all the 7 dots take because it's all a unique number. So 1 will just got all the dots take up. And we make like a frequency table like that. So basically this is how we get this model up in the plots. Histograms, it's basically like, let me show an example. So basically like A there, how many students are getting A, let's say. Let's say 1, let's say 2, let's say 3, 4. Let's say a small little class. So it's something like that. Something like that, that basically can say, well, actually like that, something like that. Let me just make this bigger and let me just make this one. So yeah, that basically conclude that this is 2, something like this is 3. This is an approximate random graph I just do. Basically, Three students got A, two students got B, two students got C, two students got D, and just the last one F, just one student got. So basically, that's how you can just model this in Instagram. Instagram, you tend to use bins, but people just tend to use this kind of graph to just show. Now here the histogram is excluding the left endpoint, including the right point. Yes, this is important. Now here in histogram, if we have a value of, let's say, from 0 to 30, okay, that means it should we just go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 till blah 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 till 30, right? Yeah, includes excludes the left one. Yeah. So this actually goes just till 30. Okay. Now from 30 to 60, this actually excludes 30 and it just comes from 31. Okay. So on this one actually does definitely count, from zero. Okay. So 0, 1, 2, 3, 4, 5 on the from the start. But after 30, it counts directly from 31. It doesn't count like 30, 31. So if you have 30, it should actually go here. Okay. If you have a value of 30. If you have a value of 31, you should go here. If you have a value of 61, it should go here. If you have a value of 60, it should go here. Okay, that's like that. It includes the left and right hand point. It includes 30, but it excludes the left end point. Yes. So the left hand point with the left hand 30 is being excluded here. So yeah, 31 come here. So basically we see 6 is actually there. 6 is between 0 and 30. So yeah, 6 makes sense. Yeah. Now if you try to see 30 and 60, 30 and 60, how many values are there? The none values. Yeah. Now 60 and 90. 60 and 90 if you see 1, 2, 3. Right. No, 1, 1, 2, I think. Oh, wait. I think I'm getting confused. Yeah. 59 and 65 we do see. So yeah, we can just model two times. Now, if you see here, 85, 86, that means we can just do 16, 90, we can just make it like, kind of two times. And 96 and 106. So 96 and 106 also two times. There you go. Let's make up. Awesome. That's how we model historical wraps. Yep. So there were 2 days only where they stand, from 30 to 60. 30 to 60 wells. So yeah, that is how we can model in historical wraps. Okay. Now here below the lens and we'll use as 8 drives from the last time she played golf. Villains. Now these are the using the data histogram. So from 0 to 50 we'll see. So 0 to 50, how many values are there? Just one, right? Yeah, just one. Okay. How many data points of 1500? So one, only one. Yeah, only one. Only one. Okay. Now here we see from 100 to 150. One, two, and then yeah, only one, two. Rest are different. Okay. This is two. And then 50 to 200. Okay. This one is actually a little bit more. Because if you see, this is 184, 177, 156. Three values. So basically if you see 3 by 3. That's three frequency. Okay, number of drives between 150 and 200 meters were how many? Three drives. It's something like, how many long drives you did in a day. You could just even model like that. Driving distance, you could say there of the week, okay, or how many hours you spend playing, whatever. Like, how many hours you spend playing, say, baseball. How many hours you spend, say, driving. How many hours on guitar. How many hours meditation. That basically you can graph up and down from say 0 to 15 minutes I spent today. Maybe tomorrow I just got a little bit, I didn't get some time. So, all right, maybe like got a lot of time. I spent like 200 minutes, from 50 to 100, then 100 to 250, but 50 to 200. That is, it gets a little bit more, then gets a little bit less. That means I can model up, where it's going up and down. Ups and downs, I can model. 113 values, so yeah, they go up, so yeah. There you go. Using data create histogram. Okay, let's create the histogram over here. So now 17, 30, 28, 23. If you see, 17 is actually no. That's actually just one value, right? So 17 is actually between this one, yes. And 23 and 20 is also between, right? And actually, yeah, 10 and 3 both are between 0 and 15, yes. So it actually should be 2 there. Okay. Sorry. So the number of points we want to see, like how many number of games are scored. So how many number of games are between these 2 points? And actually, we can even do the opposite. Number of games here, and then number of points there. So number of games, could be something like from 1, 2, 3, 4, 5, 6, like 1, 2, 3, 4, 5, 6. Or you could even do other ranges, from let's say 1, 2, 3. Like one, not very well. Like that. And then, something like 1, 3, and 6. Something like that. Like that. And there we go. I'm just trying to, do the opposite. Like number of games down, number of points above. So that point to be put here. Actually, if you see how many games were between 1 and 3. This one actually would be, oh wait. Yeah, here actually see now the opposite actually we can do because we don't know, right? Because they don't say actually 2 games were between. Like number of games we can put down, but then number of points if we try to put up there, 1 and between 1 and 3, yeah, because here we don't have actually, where they're saying, yeah, this, okay, yeah, this is important. See, the frequency always has to be on the y-axis. Okay, if you try to put the frequency down, that way it can get kind of confusing. We wouldn't be able to put the y-axis because the y-axis would kind of get blank because we don't know, right? We don't know how many data points should correlate to that. Like, how many games were between 1 and 3? We don't know actually. How 1 and 3 are the number of games. We don't know how many data points to put in there. Okay, where to put 17 or 28? How should we model that? So yeah, frequency always goes on the y-axis. Therefore, number of points always go on the x-axis. So yeah, from 0 to 15, how many are occurring? It's always occurring 2 times. From 15 to 20, how many are occurring? There are actually 3 occurrences. So yeah, because 28, 23, and 17. So yeah, 3 occurrences. From 30 to 45, how many occurrences? 33 and 42. It's 2 occurrences. That's how we can model. Because this is how histograms are being modeled. With all my stuff. So yeah. Okay, well, as the number of locations years that 2009 Omar's wallet operations locations have been opened. Using a data accurate histogram, each mean excludes the left hand point, includes the right hand. Okay, let's do this one. So 1 0 to 1 2 3 will be how much? This one, this two, and this two. Yeah. So actually, we have 5 values. We have 5 values. We have 5 values that go in here. So it will go in here. Okay, as far as we watch B. 36. 36 meaning the smart. So this one, the smart. Yeah. So basically, we have 2 points. Okay. Now, if you try to see, oh, this one is declining. Let me just read some. Okay. Okay. Now, if you see here, what is this? Let me remove this. Okay, there you go. Okay, if you see here, how many values are between 6 and 9? 6 and 9 actually just one value. How many values between 10 and 9 and 12 are actually one value, right? 10.5. So yeah, there we go. Awesome. Okay, wait, we check it out. Correct. Here it comes, yes. Now this part, okay, coming here. So coming up to here's one now. In a town, those are festivals they all celebrate diverse represents different cultures. So culture countries represented in different festivals. How many countries are different represented in different festivals? So number of festivals. So number of festivals, how many countries are celebrated? 0 to 6 countries have been celebrated in one festival. um Maybe 6 to 9, 12 countries are represented uh three festivals, and then 5 festivals are representing 12 to 18 countries. So how many festivals had 18 to 23 countries represented than 0 to 500 represented? Yes. Now this way we're talking about is 18 to 23. So this part. So this one actually excludes this left hand point. Oh, 18 to 23. I see. It excludes the right point, right? Yeah, so it excludes this 24, I think they mean. I see. So then for histograms, it keeps changing, right? In this case, they're saying that if one includes the left hand point, excludes the right hand point. So in this case, 24 is excluded, only till 23 is count. So like just 18, 20, 20, 21, 22, 20. It doesn't count the 24 as the number of countries. So basically, what you want to see is how many festivals at 40 to 18 to 20 countries are represented more. Okay. How many that represented? That represented 4. And how many 0 to 5? 0 to 5 is actually between 1. So yeah. 4 minus 1 is 3. So three festivals more had been in 80 to 20 than 0 to 5. That's what we can include from this. Okay. How many festivals are there? Yes. Now this part actually we can use all the numbers that up. All of this add up. So basically if you see, this is 1 plus 3, 5 plus 4 plus 2. Add up the value together. So 1 plus 2 is 4, 4 plus 5 is 9, 9 plus 3, 9 plus 13, plus 2 is 14. There you go. 20 festivals. Awesome. How many omega have a mass of greater than 6 kg? Okay. Greater than 6 kg. Greater than 6 kg means it should be from, I guess, from which value, let me see. Yeah. So this is basically saying the mass of kilograms. So how many pumpkins are, this mass, that mass. So yeah, if you try to put values here, more than 6 means like from here, if you see, more 6 means like 8, 8, and then this is 6. So should be like 8, this is 6, and this is 2. So you just add up all those values. So it's 60. 8 plus 6 plus 2. So 60. Okay, there we go. The theory, if you see, MRIs lives on traditional street where neighborhoods live in houses, condos, and condos. And then just saying excludes includes the right hand point, includes the right hand point. Yes. So right hand point is excluded, and then the left hand point is included. So 50 is included, 100 is excluded. So 15 to 99 only 8 count. Okay. And they're saying how many homes have less area of less than 100 square meters? Yes, that's actually we can say is number of homes. There are actually four homes. Four homes have actually an area of less than 100 square meters. If you try to see how many homes have area of less than, or say more than 250 meters, that is actually one home. Yeah, because there's 250 to 300, right? Yep. Very good. Awesome. Steven left out. Yes. Let's try this one. So Steven left out is actually, where they just represent a zero. So this one is actually representing the place value. Okay. So if you want to say we 14. So 14, how do we say like this? Let's say 4 here. If it's 24, 25, 26, 27, 32, 37, 39, like that. You can say, and if you want to say these letter numbers, you can just say 0, 5, 7, 8, like that. There's 5, 7, 8, single letter numbers. And if you want to say double digits, like, yeah, 10, I think there's just some way they represent this as well. Like, they say generally say 4, 5, so this means 105, 106, 30, and that's they say all the numbers here, like, 8, 9, 10, like that. Let's just not 10, I'm sorry, I think they don't say 10. We just say generally the single digits. So the single digits only it works. That's how we can just represent like 308, 309, 310, like that. Alright. So using that information in mind, let me go here. Uh in this case, they're saying the key is 2 and 5, that is equal to 25 tigers. So what is the smallest number of tigers at any number of zoo? That's actually 7, right? Because they're saying showing the number of tigers at each major zoo in the country. Well, one of the zoo has actually 7 tigers, right? Because one of maybe has 11, one has 14, because that is how they've graphed here. This means like 7, this means 11, this means 14, this means 18, this means 25, 25, 25, 26, 27, 27, 28. And then this is 3. Maybe this is 30, because if there's nothing there, just estimate it's 0. So this we can estimate this is 0. So this should be about smallest number of tigers is actually 7. Okay. Just, and basically now here they're asking us how many zoos have exactly 17 slots. Well, actually have 2 zoos. There are 7, so 2 zoos. There you go. Okay. Now they're saying how many zoos have fewer than 18 slots? Yes. And actually, there's a single thing, another one I just wanted to point out here is actually, in case we have like this, and we have just a 5, okay, we don't have any values here. That means actually, because of the place values, we actually have to write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but we don't have any values there, okay? That's why maybe they left there empty. So in case if we don't have that, if you don't see something, any value there, means maybe there was no value just to put it. If it was like a 50, they would put a 0 in here, okay? If it was a 50. There is no value, they just say 5, and then they just say like that. That is just representing that, 5, maybe there was no value in the 50s range, we just directly go to 60s because we can't skip in step values. Okay, we have to write them 0, 1, 2, 3, 4, 6, 7, 8 like that. We can't skip. So in that way, they just write like 5. Maybe there was no values in the range, so that's why they just write like 5 and nothing on the right. Okay, the stamp is 1, the leaf is 6, 7, 7 like that. So how many zoos are fewer than 18 slots? Well, 80 slots actually means these all part. Okay, so one zoo has 3 slots. So the zoo has 16, the other zoo has 17, other zoo has 7. So actually we have 4. Okay, the 3, one slot, one is to us 3. The other has 6. The other has 16. The third one has 17. The fourth has 17 as well. So it should be 4 zoos. But fewer than 18 slots. Okay. So this shit is for a chain of the bunch of the following step and plots for the number of classes for each of the store. Okay. Now here if we see how many department stores have more than 34 classes. 30 pairs of classes means it should be more than 38. And actually we see this is just 30, right? This is 30. So we rule out all of this data. We just check here. How many are there? 41, 42, 43, 43, 45, 47. Okay. So it means that actually 6. 6 stores have more than the 30 pairs of classes. There we go. Awesome. Next verse. Okay. Feathers that become ourselves rare feathers. Below is the number of feathers you showed today, last 8 months. Okay. Now using the data, create this graph. For this histogram, each includes. So yeah, this one is actually excluding the left hand point, includes the right hand point. Yeah, it just depends. So basically, some actually exclude the right hand point and depend just include the left hand point. If it's excluding the left hand point, it's just depending on the right hand point. So you have to exclude. Okay, left hand point. So here basically left hand point usually means what 5 is excluded. And maybe 0 is also excluded, right? Because 0 is also the left hand part. So if you excluded is just like 1, 2, 3, 4, 5. Now for this data, it's just like 6, 7, 8, 9, 10. It's just including the 5. Okay. This data, I mean, like this part. This actually excluding 5. This is including 6, 7, 8, 9, 10. And then this part is excluding 10, is including like 11, 12, 13, 14, 15. Like that. Okay. Including the right one, including the left one. Now if you see, let's see the peacocks of my father. Okay. Now here, for this part, actually, we see from 0 to 5. 0 to 5 actually is the family. Right? Now if you see, 5, 7, 7, 9, and 8, and 7. So actually 4 values. And we see 13, then 19, and then 40, right? 3 values. So 3 values are there. What are we pressing? 10 to 15. And it's not 3, actually 2. Because it's 14 and 13. And 19 actually from this. Yeah. So it should be like that. There we go. Okay. That's why includes yeah, this includes the left hand point, includes right point. Yes. So this one is actually basically where we include the left hand point. So we include 1 and we exclude 2. Okay, that's like that. So which is 1 liter actually is like 4. So between 1 and 2 is actually this part. And then this is actually between 2 and 3. Okay, this is between 3 and 4. But not including 5, not including 6, like that. Okay, it doesn't include the right hand point, it includes the left hand point. And then they're saying that how much he has drinking over the last few days is giving the data. So how many more data did is she drink 4, 5 liters and between 1 and 2 liters? Yes. So this part is actually 4, 5 liters, 4, 5 liters. How much she drinks? She like 8 liters, okay? And here every day. And then here she drank 1 and 2 liters, so she drank 4 liters. Yes. So 8 minus 4 is 4. I'm sorry. There you go. Okay. Now you see, saturation watching of store plus brand this time left and plus for the number of plus glasses that is of store. What the large number of glasses that by my store? Yes, that actually this was 47. There you go. Following French table shows the number of Jews pastimes. Pictures, I mean, they have been published in each of the following magazines. How many publish more of the Jews pictures? Yes. 2 more pictures, yes. 2 more pictures means which has the frequency of 2 or more. This one. 6. 2 more. Nothing not 2 more than 2. There's only 2 or more. 2 or more means 3. 3 is published 2. 2 published 3 pictures. 1 maximum published 4 pictures. So yeah. All together, these guys 6. There you go. Okay. Let's go. Okay. Let's go back to it. Yeah. So here they're saying this all the data here. So 2.2, if you see here, this is actually going to be 2, right? Because it's between 0 and 3, there are 2 values, okay? And then if you see between 4, so 4.3 and 5.6, okay, 2 values, and 5.1 and 5.7. The all values are between here, so we get usually 4, right? Because 1, 2, and then 3, we count here. So these two included over here. Let me change the color. So like that, okay? These 4 values get over here. And the 8.2, 7.3 will get over here, right? Yeah. So 2 values over there. You see? There you go. Just like that. Awesome. Let's me. Let's go. Next one. Let me stop this. Just a minute. Okay. So coming back to here, so when I found this graph, which are the following best to grab the shape of the histogram. So now this one is basically where symmetric left cube, right cube, right cube means basically where. Let me just get the definition here. Okay, basically let me explain. So left skewed, basically means the peak, the mountain is toward the right. Okay, the bulk of the data is toward the right. So left skewed means left is a tail. Left skewed means right is a tail. Okay, left skewed is also called the negative skewed. Okay, negative skewed. So basically that's where we have something like this. Okay, yeah. But basically something like that. Okay, something like that over there. And then basically this is the starting point. Okay, there's all the data is to keep to the right. And the left skewed means what? I'm sorry, right skewed means what? Left skewed means this part. Left has a tail. Not the small actually tail. It has actually much smaller tail. So basically Something like that, okay? Something like that means all bulk of the data is to the right. Now right left skewed, right skewed means basically something like that. Okay. So it's called a right skewed data. There's a bulk of data to the left, and then right is the whole tail. So whichever side has a tail, that means it is supposed to be the right. Whichever side has a tail, it's supposed to be that skewed. Okay, left has a tail, left skewed, right has a tail, right skewed. And the opposite has the data. Left skewed means right has the data, right skewed means left has the data. Okay. Now, which of the following describes the distribution shape of this distribution? So now here we see the left actually doesn't have much data. Left actually has a tail, right? The bulk of data is toward the right. It's more toward the right than the left. Like 10, 20 all are empty. Okay. So if all the bulk of the data is toward the right, the tail is toward the left. That means it's left skewed. Left skewed means this one. Symmetric could be something like this. Okay. Symmetric could be something like this. This is not like that. This is actually like this. So yeah, that's why it's supposed to be considered as left skewed. It has a tail towards, oh, wait. Oh, wait. Okay. I see, I see. Okay, I think I just saw you guys. I just confused. Yeah. Here actually it's actually symmetric, right? Because if you try to see here, yeah, it's almost equal, right? It's roughly symmetric. Yeah, sorry guys. If it was something like, something like that, not like that, like this or then yeah, that would be actually something like, where we would be getting a left or right skew. So yeah, it's roughly symmetric. Now here actually it is going to be left symmetric. Skew left, and let me just explain. Here if it we model the data here, now this wasn't going like this here, okay? This goes on this here. So this go like, yeah, good. So basically, we're going to each other, right? And then, they're like, let's sleep like that. Okay. So yeah, it's going to be left skip. There we go. Ah, yeah, this one. The box plot. The box plot basically, if you remember, guys, median, and then it just represents the ranges. So ranges of data is toward here. Okay. This is the range. And the other outliers, maximum, minimum values. Number of hot dogs. Contestants ate in a contest. So, maybe someone ate a way less number of hot dogs. Somebody ate a lot of number of hot dogs. What is the median of the hot dogs eaten? And what are some, I would say what was the enough number of hot dogs eaten, and then what was the interquartile rates? Just thoughts. Okay. Let me just check here. Yeah, minimum first quarter, first second quarter, third quarter. Yeah. So first, third quarter is actually, let me just explain in short. So median is basically the middle of the value, right? Now first quartile means the half value take. Because if you have 12 values, you just take the six values. You just take the middle of that. That is considered first quartile. You just have the other rest of the six remaining. You just take the quartile of that. That's third quartile. Okay. That's been graphed here. So basically, if you see the median is actually exactly at 31. So 29 is the first quartile. That is the middle of the first, six or whatever values. And then as far as 32. Okay. The minimum is actually at 24. The maximum is at 34. So yes. That means this actually should be a little bit, I would say, which one has a tail? Left has a tail, right? You guys see here. This also has a tail. This is called the tail. This is all big tail. If these two pieces, if this piece and this piece are equal, that means it's symmetric. If this piece is bigger, left piece is bigger, that means it's left skewed. Because otherwise you get a small little tail there, okay? That means it's left skewed. It's actually not symmetric. There we go. If you check here, yes. If the right half of his tail is the mirror of his left half, yes. Symmetry means right half and left half are mirrors of each other. Yep. When a distribution is skewed, it means one side of it is much longer than the right side, yes. So now here if we see, yeah. Now long whisker, yeah, this is actually called a whisker of a box plot. So longer whisker might look like a tail, but we can know the whisker represents the tail. Okay, I just caused by outlier. So yeah, in this case, it's generally best to avoid because we don't know if it represents the tail or it's just caused by a single outlier. So that way we can't really predict on the data. Because like here, if you see the data here, this is actually kind of symmetric, right? So we can predict based on the box plot because the whisker actually could be representing a tail or it could be representing a single outlier. So we can say right and left skewed. We can just say symmetric or not symmetric, okay? But we can definitely say that it is much more spread out than the right, okay? We can just definitely say that's not a mirror image. So we can definitely say it's not symmetric. It's not symmetric because it's not, caused by this shape. Like the shape doesn't have, I would say like, it's not exactly symmetric because there's an outlier that is actually breaking the pattern. That is actually breaking the pattern of the symmetry. That is a reason we can say. And we still see the reason, just a minute. What can we say? This. Okay. So yeah, let me just get some explanation here real quick. I'll just explain you guys. So let's go to the next one actually. Yeah. Without a following shadow distribution, yes, there's actually a symmetric, right? Because it was actually kind of like that. So it's symmetric. Yep. There you go. So yeah, the box plot actually doesn't show the full shape, okay, like histogram. So it could be roughly symmetric because it's like the left and left whiskers, right whiskers are the same. Like if the box has the median and the first quartile, second quartile are actually, that space is also like first quartile to median, and then from median to the third quartile, like this part. This is kind of symmetry. This isn't symmetry, right? Or this is too big, like this, and this is too small. That means we know that it's definitely not symmetric. But based on if it's not symmetric, we can say definitely it's skewed or not. Okay, because they're not symmetric doesn't necessarily mean that it's actually kind of some skewed. Oh, let me see. Uh, yeah, in some classes I think they do teach, right? Like skew direction is longer whisker, but in real stats is generally not the case, right? Because it could be caused by an outlier. So it's generally safe as it's slightly right skewed or something like that. Because in interstats, I think it's fine, generally to conclude if it's skewed or not. But in this kind of thing, it's generally hard, like in real stats, to conclude if this is skewed to the left or right. So yeah, this is what definitely roughly skewed. So let's anyways go to the next question. Dot plot this one. And which of the okay, this one is also symmetric, yeah. Because this one is actually kind of like that. So yeah, there you go. Awesome. Let's see. So I'm going to distribution. Okay. That's what I'm saying now describing distribution. So now if we see this distribution, the shape of the distribution. So shape means what? Shape means if it is skewed or not. Okay. This means it's going to be skewed toward actually. This is the center. Okay. And if we actually see here this part, then this part. Okay. Then we have this part here, then we have this part. And actually, if we take these two parts of this one part, okay. So this part actually, if we take this small part and we take on, well, um, what is the center? This is the center, right? C center. So shape, I think would be we could say something like. Let's actually try that here. Think this would be something skewed to the right, if I'm not sure, if I'm right. Yeah, center would be they're saying median of the amount of sleep is somewhere between. Yes, somewhere where would the center be? Let's see. The center of the median of the sleep would be somewhere between. This part actually we need to conclude by taking a look at for 50 days. Okay, for 50 days. Now 50 days means what? The median should be which values? Remember, in the median we have actually from the n, how to get the formula is. Again, let me see the formula. I think there was a formula here. Let me see. Yeah, it's basically if the n is r, the formula is supposed to be n plus 1. Over 2. Okay. So, but here in case this is actually even, so it's supposed to be n over 2 plus n over 2 plus 1. Okay. Otherwise, we see here 30 divided by 2 is 25. 25 plus 26. So 25 plus 26 the average of that. Okay. 25 plus 26. Now we have to count over here 25 to 26. How where do we get those values? Okay. So if we see here 25 to 26, the 25 to 26 value, where should we get here? So if you see, this is actually two values. So this is 9. So 2 and 9 is just 11. We just avoid that. This is 12. So 12 plus 11, that is about 23, right? So 23. Yeah, now this is I think part. So yeah, this is actually 2. 2 plus 9. 9 plus 12, right? So 2 plus 9 is 11. 11 plus 12 is 30, 23. So this is all 23 till 23 parts. Now this is the part actually. So I'll just write it in, I'll highlight in different color. It's actually containing the measure. So 7.5 to 8, because that should contain 25 to 26 value, right? It's such a big column. It contains almost 12 values. So 23 to 35. So that's where somewhere 25 to 36, because this contains from this one contains from 23 to 35. Okay. That's actually where 25 to 26 sit in between, right? So that should be between 7.5. Oh, sorry, 7.5 and 8, right? Yeah. Yep. 10.5. Spread. Now, how the spread is the spread, the range of the amount is actually what is the minimum? What is the maximum? A minimum is 6, maximum is 9.5, right? So basically, we could say 3.5. Right? 3.5 would be a Approximately 3 hours, I think. Something like that. How many outliers are there? Actually, none. Let's check that out. Oh, it's incorrect. Hmm. Is this rheumatoid? Let me see. Oh, I see, I see. How come it's symmetrical? Let's see. Oh, yeah. Right and left sides are approximately similar images. I see, I see. Yes. I think what they mean here is basically that this part is symmetrical image of this part, okay? Something like that they mean. It's not something like, I think it should be like too much pulled, okay? It's kind of a little bit hard to tricky to see from the drawing, but it should be too much pulled to the right or left, then only we can conclude skewness. So yeah, I think that's how they conclude here. I see. But I think the parts was correct, right? Yeah. Okay, great. Let's go to the next question. Many people require more than one attempt to pass a drawing test for adult lessons. The Rappler shows number of times 20 people take drawing test in order to earn their driving lessons. So yeah, they took how many tests? Some people, they require even 6 tests to take a driving lessons. Maybe they just failed that was test. They took second time, second fail, third fail, like third time they took third fail like that. So basically, if you see here, now this one is actually right skewed, right? Because this one is actually has just right pillar, but something like that. So now this one actually has more data toward the right. So this one actually should be more right skewed. Yes. Center should be actually where center should be 21. So 21 divided by this thing. 21 plus 1 over 2 because this is an odd number, odd n. So we just take is 21 plus 1 over 2. That is actually 22 by 2, that is 11. So 11th value we have to find out. 11th value would be where? These are the 7 values. This is 8, 9th, 10th, 11th. Yeah, this is the 11th value. So 11th value is actually roughly at 2. So that means it should be 2. So it's 2. What is the spread? Spread is actually going to be how much? It's going to be 5, right? Because it's from 6 is the maximum, 1 is the minimum. So yeah, it's going to be 1. 5. The start. Let me just say that. There we go. Okay. Yeah.